Testing, testing. 1, 2, 3. Testing. Welcome to week 4, session 1. Can you hear me well? How's the audio? Is the audio good? It's clear? Good. Oops. Wonderful. Super awesome. Great, 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 great. Great view. Speaker view. Title view. Wonderful. Great, wonderful, great. Fantastic. So what are we going to do today? Review homework 2, homework 3, culture quiz, and the first law of UX called design superiority effect. Time to pray. 10-minute break. Be back here at 6:43. See you in 9 minutes. Great, awesome. Alexa, timer 6 minutes.
6 minutes, starting now.
No, come at 7:30 because I'm giving a lecture. So 7:30 sharp with the path from here. Okay, okay. Is everybody back? Not yet. All right, who's back? Yes, yes, no. Somebody's not back from break. Okay. Are you back? Okay, shall we start then? Yes, good, wonderful. We're 50. Alexa, stop. Good. Welcome back, everybody, to week 4, session 1. Before we start, any questions? Any questions? No? Good. Okay. You have a question, doctor? Quiz today? No. When is the quiz? When is the quiz, winner? Wow, 20 different answers. Okay, so when is the quiz? We can check it on Slack. What does it say here? Can somebody read that? September 14th. Sounds good? Very good. Tuesday. Yeah, are you ready for the quiz? I set up a Google Docs where you can suggest questions that you think. This is, for example, an example question. So you can practice here. It's great if you add your suggestions here as well. I will give you bonus points for the best questions proposed. If I like your question, I might add it to the quiz if it's good. Sounds good? So you have no excuse not to get an A. Winner, you have a question about Fitts law. Do you want to do it now or after? We'll do it after. It's a short one. Go ahead, open the mic and ask.
Can you hear me, doctor?
I can hear you loud and clear, Winner. What's the question about Fitts law?
Okay, doctor. I'm confused a little bit about the formula that we used while discussing in the class and the formula in the video that you sent to us, because when we were discussing in the class, we were just considering
Winner, stop. Winner, stop. This question, much better asked on Slack. So you post both links and you say you're confused, and then we will answer it on Slack. It's so much better. Yes? Winner, okay? Sounds good? Much better, because we're 50 people here. So post it on Slack. Maybe some student has the answer to that question. Way better. Any other questions that cannot be asked on Slack? Good. Another question I have, did you do the culture test? You do it? Okay, it's 1 point, and 1 point is usually the difference between an A and a B. So this quiz is compulsory. If you don't do it, don't come crying at the end of the course. Sounds good? You have to do the quiz. It's compulsory. Why is it compulsory? Because even though we spend 1 hour about how to use Slack, how to use email, still are students that are not following the rules. And if we don't follow the rules, it's a chaos. And that's why we have rules. Sounds good? So don't miss it. It's graded. You have to do it. Another question. And it's very easy. So it's easy point to get 1A, and you can do it as many times as you want until you get an A. So do it. Clear? Sounds good? Okay. Now we had some volunteers to show the homework 2 and 3. So would any group want to go first in showing the homework? Like, I think Salama Mohammed or Khalifa. Not me. You answer here that you would like to explain. Salma, sorry. Salama. No? Okay. Anybody? Any volunteer to show the homework? Winner? No?
Okay, so
Yes?
we can, okay.
Yeah, would you like to present homework 2 or homework 3?
2.
Is that a yes?
Yeah.
Okay, go for it. Which group number are you, winner?
14.
14. Okay, go for it. Let's see. Can I make you everybody's moderator so you can present? Yes?
Okay, I'll share my screen.
Khalifa, you who wants an explanation versus who wants to explain in class today? I see. Got it. Okay. Well, don't miss the deadlines for the homeworks. You have infinite submissions until the deadline. So if you miss the deadline, I cannot help you after the deadline. I can help you before the deadline. So that's one thing. If you want to get an A, keep that in mind. All right. And remember, it's free to ask questions on Slack, and we're here to help you get an A, so don't be shy. Oh my God, who did that? Wow, this is very cool. Saed. Wow, this is great. This should be posted in general. Doctor, you forgot the option, not me in the poll. No, I didn't forget the option, it's on purpose. Right, winner, are you ready?
Yes, doctor.
Okay, you can share your screen whenever you're ready. Winner, are you ready?
Can you see my screen? I'm sharing, doctor.
Yeah, we see it. Go ahead.
Okay. So, me and my group members tried to do on the Fitts law. So it explains the effect of the distance to the target and the size of our target. So this was as we showed last time, our default.
Wait a second, winner. Wait a second. You're going very fast. Can you explain again slowly what is Fitts law? What does it tell us?
Okay. So Fitts law explains that the time to reach the target depends on the distance from the target and the size of the target. So as the distance from the target gets larger, the time to reach the target will increase, and as the size of the target increases, the time to reach the target or the work to reach the target will be less. So which means there will be the cost to reach the target will be lesser when the size of the target is bigger, and the cost to reach the target will be much more difficult when the distance towards the target is far. So in order to explain this law, we try to manipulate the graphical interface of our calculator. So in order to do that, we try to change some one of our buttons position at 4 places. Then we did the experiment with 10 samples. So you can get our calculator from this GitHub application actually. So when first we discussed as we saw together last time, our button was smaller or like this one. This is 4, 5, 6, and the below buttons are the default ones. So when we double the buttons, so there are the data is here actually, but let me explain from this picture. So we took button 1 as our initial position, and we took the clear button as our target position. So whatever we do, we'll do with this clear button, starting from button 1. So for example, if I show just one of our experimental things, so this is a calculator. This is our one of our sample or testing calculator. So this is one is our initial position. So I click one and I try to go to clear. So the time it took me is 1.66 seconds. So if I try to do it again, it's just, so we tried with 10 people and we registered the data. Then we took the sample, the average, so that to avoid any bias. So when the width is tripled, it looks like this. When the distance from 1 to clear is doubled, clear will be from here, around here. And so as the distance gets larger, we will see from our results that the time to reach the target will get larger. So this is the graphical phase that we see. So we're asked to draw a graph or based on the time elapsed and our difficulty index. Difficulty index is just logarithmic part, this one.
Oh, wait. No, winner.
Yeah.
The difficulty index is just the thing inside the formula, not the logarithm part, okay?
Oh, really? But when I search about it, it includes the log part.
Okay, can you send me that reference, please? Later.
Okay,
Sounds good.
let's
Go for it.
Okay. So this is our trial. So the default distance from the button 1 to the clear button is 250 pixels, and the width of our default button was 50. This is when it's the original one, the default one. So we measured the time it took to go from button 1 to the clear, like 10 times. We sampled 10 people. Then we took the average. So using this width and distance, we calculated the difficulty index. So we have the difficulty index and the time delay, the average time delay. Then we change the width twice. We make it 100, and we fix the distance was constant in order to avoid the variance that happened because of the distance. So distance was fixed, and we make the width twice. Then we measured again with 10 people. Then we took the average, and also using the width and the distance, we calculated for the difficulty index. Then now we fixed the width. It was 5, it's 5, and we make the distance twice, which is 500 pixels. Then again we took this thing. If you see from our sample, as we can see, the original one was this 0.636, but when we doubled the width, it's getting lesser because as the target size increases, the time elapsed to reach the target is getting lesser. So see, here is 0.63, here 0.506. So when the distance get farther, now we can see it's getting larger. It was 0. Now it is 0.837, and when the width is getting even larger, now it's also getting much smaller, 0.488. And when the distance is 3 times triple, it's going much larger.
Wow.
So we try to draw this thing. Okay. So we try to grow our work. So as we know, the formula looks like this. We took the log part as the difficulty index. So b times id will be like this. So as we can see, this is a linear. It looks like a linear equation. So the relationship between the time elapsed and the difficulty index is linear. So since our sample is smaller, so it won't be a perfect linear, but it shows us the clue that as our sample size increases, it will show us a linear relationship between the difficulty index and the time elapsed. As the difficulty index increases, the time elapsed also increases. So as we can see from the graph, this direct relationship between difficulty index and time elapsed is displayed. Therefore, you can conclude that the difficulty index, as the difficulty index increases, so does the time to reach the target. So you have to remember that the difficulty index depends on two things: distance from the end width of the target. So if we try to grow the logarithmic graph, we try to take just let's take case first, case 1 and case 3. Case 1, case 3, and case 5. Let's see which case are this. Case 1 is the original one, and case 3 is the third one when we make the distance twice, and case 5 is when we make the distance triple. So let's see the effect of just varying the distance while fixing the width. So this is the result. This is our result when we vary only distance. So you can see it's not like a straight line, but it's like a little bit curved one because we're just taking 3 samples. So it won't be a perfect logarithmic curve, but we can see that if we increase the number of points that we took, or if we make it like 4 times, 5 times, or if we did more samples, it would have been a perfect logarithmic curve. So using this one of these two equations, we calculated the value of a and the b because we can create a system of linear equations. So MT we have our time and we have the difficulty index. So for our sample, we just took 2 of these 2 rows. So we substituted MT, the time, the ID in place, the difficulty index here and the elapsed time here and also here. So these are equation 1 and equation 2. So equating them by elimination method, when we subtract equation 1 from equation 2, we get 0.636 minus 0.506 on the left side, and a minus a is actually 0. Then we subtract this thing, and so finally we find approximately the value of b is this one. Then we substitute 0.133 in place of one of the equations, and we get this. Actually, this is not the actual result, but approximately we believe that the value of a is 0.149 and the value of b is 0.133. So this is sorry, here there is a typo. Sorry. So to sum up, our experiment, we have got good evidence supporting Fitts law, which states that the distance from the sizable target affects the time to reach the given target. Even though the sample size we use is smaller, give us a strong belief that the result will be more vivid when the size is large.
Wow.
So
Okay.
thank you. This is our part.
These are milliseconds or seconds, or what is it?
It's in seconds. It's in seconds. So as you can see in one of our sample things. So if I click 1 and if I go to clear, it's in seconds, 1.149 seconds.
Okay, questions? Anybody has a question for winner? Okay. Wait. Yeah. Wow. That was really impressive. I have something for you. This. Everybody clap.
Thank you, Jimmy.
That was amazing. This is the best homework solution that I have seen this year. Yeah. Who wants winner's homework solution? Yeah, I think everybody wants it. Maybe you can drop it on Slack general channel because people maybe want to see how you did it. It's really good. Well done, group 14. Anybody else would like to share the homework? So winner, in your opinion, doubling the size of the button shaves 100 milliseconds, more or less, we saw, yeah? So what do you think about that? Like, how do you think it's important to shave this 0.1 seconds every time we click, or what do you think about that?
Yeah, it's more effective. I think it decreases the cost of the user. So it helps for us if we make some product, for example, maybe mobile or web applications. It's simple to do for us, but it makes a lot of difference, especially if you have a lot of buttons. So it means a lot.
Can you think of a time? Oh, Moet has Moet has a question. Yes, Moet. You want to open the microphone? Yeah. What can you think of a situation when you don't want this, when you actually want to make the button hard to press?
For example, if I don't want them to leave the page, so I may make the button like small or something.
Or the button delete everything, right? Maybe that one should be not
Yeah.
easy to reach.
Yes, like
Yeah, which is a
example
very
in
cheeky way.
Amazon.
Yeah.
Yeah, if in
Okay.
Amazon, for example, the button to delete the item from the cart is very small.
I didn't know that. Really? Send me a screenshot. I'm gonna send it to Jeff Bezos. Wow. Okay, very good. Congratulations. That was a very good homework. Please drop it on, share it with the rest of the students. Rhoda, absolutely, yes. Rhoda, can you present? Wow, we're 53 today. Everybody's here. Wonderful. While Rhoda presents, I'm going to do the attendance, but everybody's here. So let's do it. Attendance tracking. Week 4, boys, everybody's here. Wonderful. And now week 3. Rhoda, whenever you're ready, we are ready for you. Wow, full house. Amazing. Okay, who's next? Rhoda, yes, please.
So how do I share the PowerPoint?
You're asking the wrong guy. So I don't know anything about computers. Somebody can help Rhoda, please. She's not, wait a second, I will make you moderator. Rhoda, don't move. Okay, hold on. Rhoda, are you moderator now? Rhoda, yes, you are moderator. Rhoda, you may now have the option. In share content is the third tab downstairs. Good, wonderful. Okay, remember the point of this is to learn, not to judge. So if it's perfect, we don't learn a lot. So it's more fun if.
Sorry, how do I open it specifically on the PowerPoint though?
Just share the whole screen. It's okay. It doesn't work sometimes. It's not very good.
Okay.
Share file. Okay, good.
I just zoom in like that. Okay, so I'm in group 6, and today's explanation is about the Fitts Law homework. Fitts Law is pretty much.
Can you zoom in?
Yeah.
Zoom in a bit.
Oh,
Can you zoom in the document a bit? Yeah,
like
thanks.
this. Okay.
Not too much. Not too much.
Like this. Okay. Fitts Law is pretty much used on GUIs, anything technical. It kind of says that the smaller the button or the longer the distance, the harder it is to use the program. Okay, so we conducted an experiment. Two GUI calculators. One of them has a good design, the other one is the bad design, which means this one has the longer distance and smaller buttons. And we measured 2 things, the time taken to actually calculate and the difficulty rate. 0 being the easiest and 10 being the hardest. Each of us conducted the experiment. 5 of us. Okay.
Sorry. Wait.
Yes, sir.
The time taken, you gave the users a specific task. Is that correct? Can you explain us the task?
We
And
told them to. Yeah.
The difficulty rating, can you explain how you got that? Just a little bit.
Okay. We used the stopwatch and we told them the calculator is over here. Wait, I think the slide is a bit broken. Over here. We told them to add, subtract, or you just use the calculator normally, and as soon as the answer popped up, we hit stop on the stopwatch thingy, and it was so fast for when they used the good calculator, and it took way longer when they used the bad one. We asked them to rate the difficulty, like how easy was it when they used the good calculator compared to the bad one. everyone kind of agreed that the bad one was very hard. And it took way longer to calculate what they wanted because of the ugly buttons. Okay. We attached the code of the calculator on Blackboard, and we made a chart pretty much saying the difficulty and the time and comparing them both. This is for the good one, that's for the bad one.
Wait a second.
And,
Stop.
yeah.
Each user is a dot.
Yeah, this is each user.
You have to come to my visualization class because this chart is not okay. It's great, but usually you don't want to connect the dots when there is no relationship in the connection. So in this case,
Okay.
you want to use a box plot, it's called. I'll show you
Alright.
later. And then you plot the mean, the mean of both
Yeah.
as a line, and then you really can see the dispersion and the mean. Box plot is what you want to use for this one. I will write it here if you want to get an A+.
Alright, sir. We'll do that.
Go for it.
Sorry. Okay, and this one won't. To conclude it,
it's a big difference, yeah.
Yeah, okay. To conclude it, the bad design. There's a very big difference, obviously, between using the good design and the bad design. Yeah, and if we want to make our programs more desirable, we go for buttons that are easy to click rather than something that looks like this. Okay, thank you.
Wait a second.
Yeah.
So here, wait a second.
Okay.
Questions?
Questions, anyone?
Questions, anyone?
No? Thank you.
Okay, let's give it a hands.
Yay.
That was pretty amazing too, right? That's wonderful. Great, good job. So Jennifer Lopez, we said in the rules of the class that we use real names. And if you don't use a real name, you will be kicked out of the class. Sounds good. Does that make sense to you? Because we already have enough cows in our world, so please change your name. And can you invite me to your WhatsApp group, HCI, both sections, please? Because I'm also a member of the class, no? So I don't think it's fair that you make a group and the teacher is not invited. What is that? Yeah, right, exactly. No, not cool, not cool. Okay, good. So, okay, so I have a comment, Rhoda. So what you want to do in this case, it's a box plot. So a box plot, it looks something like this. You see that?
No.
Oh, you don't see it, of course not. Hold on a second. Search, application screen, here, bang, bang. Okay, cool. So a box plot is what you want to use in this case, where 1 is the good design and 2 is the bad design, and you have 2, right? And so these are all the dots here represent 95% of the dots. The line represents the mean, and this represents the outliers, or I think this represents 65% of all the dots, and this represents 95% of all the dots, and this the outliers. And it's a standard way to show this. Unfortunately, Excel doesn't have, oh, here it is. It's the median, not the average. So it's the scientific way to show it. There are many ways to do it. Our language has another way to show it like this. So here you can see the dots, the data points inside, right? So you actually can see how many data points. So that's a cool way to show it, because then you can really have a real sense of how much they overlap and if the difference is significant, because sometimes, in your case, it was very clear, right? And so it's very nice if you add the difference between both means, like Winner did. So I think that's very, very cool if you want to get an A++.
All right, sir. Thank you. We'll use it next time. Thank you.
Yeah, that's like, yeah, it's very good. If you, like, here's another one without the boxes, but you can see the same concept. Another thing you could use, or here's an horizontal one. And so pretty easy to use. Here's another one from our language ggplot, so you can see the dots here. Right. So scientists are used to see these box plots, they call it. Here you can see another one. Here you can see another one. Sounds good? Excellent. But for this, you need to use Python or our language. Wonderful. Another crazy option would be violin plot. There's another one, but in this case, it's a density plot. So the density of the dots like that. And it's equivalent to a box plot. So in this case, you see a box plot inside and the equivalent density plot as a violin. So where it's thicker, there's more dots, and where there's thinner, there's less dots. So you can see actually the shape, more information, right? So, and so on. Good. And that's for data visualization today. It's so cool, these plots. Right? Anyway, that's for A++ next time. Wonderful. Anybody else would like to present? Okay, let's go for homework number 3. Anybody has something to show? You were asked to show some UX famous fails from the internet. Did you find anything interesting? No? Nothing? Nobody? Okay, nothing? Nothing to show? You didn't find anything else? Okay, good. Do you have any questions about the homework number 3? Homework number 3. Okay, are you gonna do it? You want to do it? Are you excited? Do you have any questions about the homework number 3? Or you think it's not important? If you have a question, ask now. Now it's the time. No? Okay. No? Okay, good. Wonderful. Okay, good. Right, so let's see the law of, can you delay the date 1 or 2 days, Mohammed? Yes, that's possible. Is there any reason for that? Why? Because you have the quiz or you have a lot of problems? Yeah, it's a very easy homework. It's like 20 minutes. It's nothing. Like, just find some famous UX, just research a bit. This is an exercise to force you to research a bit. You go to Wikipedia, you'll find many examples. Oh, I'm so sorry. Okay, including ours. Good. Okay, fine. But I have some good news for that. Okay, today's UX law is the law of design superiority. Okay, are you ready for it? Can somebody tell me what this law is about? Can you imagine what this law is about? What do you think? What is it? Here. Anybody can think why this law might be interesting? No, nobody? Okay, good. So we're gonna watch 30 seconds of this video. I have to cut the sharing and restart again in Chrome tab with sound. Good. Right. Okay. Do you see the guy?
Product designer John Yablonsky recently created an incredible website outlining.
Yeah. Can you hear the sound? Yes. Good. Awesome. Wonderful. Let's see it.
outlining the maxims and principles that designers can consider when designing user interfaces. It's called Laws of UX, and John was kind enough to give me permission to bring his principles to you in this video. Over the next few minutes,
This is the book we're using for the first 2 months here. By the way, it's the same book.
you'll learn the names of these 19 principles, along with their origins and how to apply them. Let's start with the aesthetic usability effect. Users often perceive aesthetically pleasing design as design that's more usable. In 1995, researchers Masaki Kurosu and Kaori Kashimura from the Hitachi Design Center tested 26 variations of an ATM UI.
How many variations? How many variations? 26. That's a lot. Yeah, that's a lot. So Hitachi is a Japanese company. They make ATM. So if you use an ATM, it's probably made by Hitachi or Fujitsu. If you look inside the machine, it's not made by the bank. Good, let's go to it.
They found a stronger correlation between the participants' ratings of aesthetic appeal and perceived ease of use than the correlation with actual ease of use. The Doherty threshold.
Right, so what does this mean? This means that if you make a beautiful design of the calculator, beautiful design, or a non-beautiful design, the users will think that the beautiful design, even though they work exactly as fast as the other one, that the beautiful design one works better. You have this effect with people too. We know that from psychological experiments, more handsome people are perceived as being more intelligent, competent, likable, and less handsome people are perceived to be less competent, less intelligent, and less likable. Does that make sense to you? Even though they are exactly the same person, or even though they are exactly the same calculator, a calculator that has a better aesthetic, it's another way to say beautiful. The users will think it works better. Can you give me an example of that? Can you give me an example of a famous brand that uses this to make people pay a lot of money for their laptops, computers, and iPhones? Oh, sorry, I said it, iPhones. Exactly. Can you give me another example of that? LG, okay, I don't know that one. Samsung, what do? They make beautiful fridges and people think they freeze more. Yeah, so that's correct. Sony and Microsoft, Asus, okay, yep, wonderful. Sports cars, and so on and so on. And that is why it pays off to make beautiful designs, not only make people happier, people think the product is better. Do you believe this? Okay, so this is your kinda, yes, a lot. Okay, good. So let's truly learn this and believe it. So I put an assignment, a group assignment on the Blackboard, and your assignment is to choose 2 products to test. One is Teams versus a different Teams called teemyco, and the other is, give me a second. Hi, sorry. And the other one is teemyco. So can you see my screen? Testing. Can you see my screen? No, you cannot see my screen. Sorry about that. Hold on. Can you see my screen? Okay. So the other one is teemyco. What is it? Here, teemyco. Teemyco. Teemyco is a Microsoft Teams. Tab is deactivated. Okay, it's not working now. But let's see. Team. Okay, teemyco. Teemyco. Can you see my screen? Yes. Teemyco is a something like Microsoft Teams, where you have actual places to sit down virtually, and the design is different from Teams. So your job is to try to measure this aesthetics law. And this is your next assignment that you can do in the next class after the quiz. It shouldn't take more than 30 minutes to do it. Sounds good? If you don't like to test this Teams thing, you can test a different product with Miro. You all know Miro, but there's a different alternative to Miro. It's called Milanote. And Milanote, you can see it. You could say it's, wait, come on, give it to me. No, not coming. Let's see. Milanote is, let's see. Milanote is kind of designed by architects, so it's different. So if you don't like to compare Teams to teemyco, you can compare Milanote to Miro, and then run a small survey and try to see if people think that one works better than the other. Sounds good? So this is your assignment. It's H homework 4, and the next class we have the quiz. The quiz will last 20 minutes. After the quiz, you'll take a break, and then you can start working on this after the quiz or during the weekend. It should take 30 minutes, 40 minutes to do this. So try to find, you can test it yourself between yourselves, or you can find victims in your household. Questions? Everybody sees this assignment? Yes? Wonderful. All right, cool. Questions? Right, good. All right, good. Questions? It's group work. If you don't see your group, let me know. But I set it up as group work. You have to write a small report, 100 words, with maybe the statistics. Okay, we did a survey, and people find out that these two pair of products work very similarly, but the design aesthetic is different, so people think. So let's see if you can measure the law. Right, good. For the quiz, so practice what you have online. Suggest questions, what enters in the quiz, everything we're saying, the laws, fits questions, and so on. You have the examples here. Questions will be very similar, obviously with different numbers. So yeah, good. Any other questions? No? Okay. Well, let's give it a hands to the people that presented today. Very good work. Well done. And I will see you Tuesday for the quiz. Questions, Slack. Sounds good. Don't forget to do the culture quiz. It's graded. It's easy to get points. It's like free gift for you. All right. Good job, everybody. Winner, Roda. Congratulations. That was amazing homework you did. Please share it on Slack so people can get inspired by your homework. And if you get inspired by their homework, please say it in your homework. Good job. All right. I'll see you soon. You may now leave.